All right, second video. This is going to be dealing with conjugates, right? So you're looking at this problem, it's a little bit different. You can see here that I have a real number and also a rational number and an irrational number, like an imperfect square root in the denominator, which kind of creates the same problem. I still have a denominator with a radical, so it's not fully simplified. Right. So if you're thinking, well, I can get rid of this denominator by saying, all right, well, if I multiply, the top and bottom by radical 2 over radical 2, that might cancel out with there. But you got to keep in mind, this radical 2 would actually be distributed to both parts. So my numerator would be 3 radical 2. My denominator would be 7 radical 2 plus, if I distribute the radical 2 to the radical 2, I just get 2. So that part's now real, but in doing so, I've actually created a new problem. I've got a radical now on that side. And that process would repeat itself over and over and over if you keep doing it. So I compare it to BPA, right? They introduced a chemical for BPA so that they could make plastic things BPA free. What they found is that the chemical that's replaced BPA pretty much does the exact thing as BPA. So like you're creating a new problem by solving a problem if you do it that way. So it doesn't quite work that way. What we need to do is we need to multiply the denominator by its conjugate. Conjugate's a word we're going to use all the time this year. So it says right here, if we have an expression a plus radical b, right? The conjugate of a plus radical b is simply a minus radical b, right? And it doesn't even have to involve radicals. A plus b, a minus b, those things are conjugates of each other. But their product is always going to be a rational number, right? Which is going to be good because if we have a rational number in the bottom, I don't have a square root, that's going to be great. So in my example here, right, if I have 3 over 7 plus radical 2, I'm going to multiply it by 7 minus radical 2 over 7 minus radical 2. And again, that's the same thing as 1, right? The same thing in the numerator divided by the same thing in the denominator. That's equal to 1, so I'm not changing the value of anything. But what's going to happen, right? So my numerator, I'm going to have to distribute. My numerator is going to be 21 minus 3 radical 2, which isn't pretty, but that's okay. And then my denominator, you can see what's going to happen. I'm going to have to FOIL, right? I got 2 terms here and 2 terms here. So when I FOIL, right, I'm going to get 7 times 7, which is 49. I'm going to get 7 times negative root 2, so that's going to be negative 7 root 2. And then I'm going to get root 2 times 7, which is positive 7 root 2. So you're probably seeing what's happening there. And then root 2 times negative root 2 would just be negative root 4, which is 2, right? So then you can see here the beauty of conjugates is that it will create a positive value of your radical and a negative value, a positive and negative. But these two things will cancel each other out. Positive 7 root 2 and negative 7 root 2 cancel out. So then 49, minus 2 is just going to give me 47 on the bottom. So I got 47 on the bottom. And then my numerator, again, it's not pretty, but it's 21 minus 3 root 2. And so mathematically, this is equivalent to what I started with, but this one does not have a radical on the bottom, which is why it's simplified, right? So, yeah, so this, if you have this note, a minus b is an irrational number, a plus radical b is an irrational number. But when you multiply them, you actually can get rational, right? And then, so I want you guys to do this one practice, and then we'll move on to our third video. So do this one on your own, and then pause the video, do this one on your own, and then resume the video when you're done. All right, so for this one, hopefully you guys have figured out the conjugate is 5 plus radical 2, and we're going to multiply that by numerator and denominator, so it stays equal to 1. And so when I distribute, I'm going to get 20 plus 4 radical 2. And then my denominator, I'm going to get 25. And you don't even have to write out the foiling with the middle two. They're always going to cancel. So if you want to get in the habit of just skipping like the middle two foiling steps because they'll cancel each other out, that's fine. And so I'm going to go right to root 2 times root 2, which is root 4. So it's going to be minus 2. And so then my answer would be 20 plus 4 radical 2 over 23, right? And nothing's going to simplify there. If this was 22, though, then all 3 terms would have an even number, in which case I would want to divide them all by 2. But in this case, I can't simplify any further because the three numbers there there's nothing that goes into all of them, right? So that's that for that video.